This video will be in part. Nothing, right? Nothing weighs exactly one. Is there something? Oh, why don't we set something equal to exactly 1U? You could, but why did they pick carbon 12 and why did they call it 12U? Yeah, it's convenient. You can get it in high purity. It's cheap. Everybody can get it. Nothing difficult to obtain. And it's not particularly toxic. If you use something else, I guess oxygen's also good. Oxygen used to be the old one. Do you know the old standard for the U? Remind me what the old standard for the U is. Oxygen 16 weighs exactly 16U. Good. Did you just remember that from lecture, or did you? Okay, wow, good memory. Good memory. And so when did the transition change from oxygen 16 to carbon 12, roughly? Yeah, something like that. Yeah, 50 or so years ago. Good. Okay. So if you look at old data tables, all the masses are all different because of that. Okay, the next question I have for you is this. How many sig figs do you think we can weigh? If we put a bromine chloride into a mass spectrometer, hopefully it didn't break apart, but the bromine chloride lands somewhere, and then we measure its mass. Its mass is going to be less than 114 somewhere. But how many sig figs do you think a mass spectrometer can weigh that to? Or how many decimal places do you think it can weigh to? You don't have to give me an exact number, just a lot or just a few? What do you think? How precise is a mass spectrometer? Just how many decimal places do you think you'll be able to get at least? Just look at your notes. Or the periodic table. Look at the periodic table. 3 or 4 or more. 6. Easily 6 decimal places, mass spectrometer. Some of those, are fewer sig figs because it's not because of the mass. They're fewer sig figs because, or decimal places because of, not because of the mass, because of the, no, not because of the mass defect.
Adding together.
Not necessarily. There's one other thing. Those numbers in black up there are from what? I really didn't talk much about this because it's a review. I mean, a lot of people do these calculations pretty easily. Where do those numbers in black come from? The weighted average, right? It's the weighted average of all isotopes. Boy, this should be, I was thinking I'd just skip this because a lot of people do these calculations are pretty straightforward. You know, they cover it a lot in Chem 4. You know. Still planning to skip it. I'm not even going to bother doing a calculation for this. You just take a look at the homework. It's pretty straightforward calculation, but it depends on the mass of each isotope and the abundance, the percent natural abundance. So it certainly comes from the percent natural abundances there. The percent natural abundances, those are averages too. They get samples and collect samples. Actually, the percent natural abundances change. For example, oxygen at lower altitudes is more rich in oxygen 17, oxygen 18. But as you get to higher altitudes, you know, the oxygen 18, oxygen 17 abundance goes down. And not only that, it depends on you know, other factors too, like you know, source, etc. And so those percent natural abundances, sometimes they limit the precision that we know these two. All right, this is another, again, pretty soon I got to kick up the pace because we got a lot of stuff to cover, and I'm not going to review much after this. But this 34.9689, that's the mass of chlorine 35, right? No, it's 35, but is the mass of chlorine exactly 35? No, the mass of chlorine is 34.9689. Now, you look at this number, 34.9689U, and can we tell anything about the accuracy of this number by looking at how many sig figs? For example, the more sig figs, the more accurate? No. Yes or no? True or false? The more sig figs, the more accurate? That's false, right? That's false because, yeah, maybe the mass spectrometer wasn't calibrated properly beforehand. But in general, the higher the precision, you'd expect the better the accuracy because you're working with a more sophisticated instrument, and you expect that whoever's using an expensive instrument knows how to calibrate it properly, right? And so you'd expect some to be reasonably accurate. Okay, so 34.9689. So I want to know how much a bromine chloride weighs. This is chlorine 35, this is bromine 79. How much does this weigh? I know it's going to be about 114 U, right? But it's probably going to be less or more than 114. It's going to be less, right, as we just said. And so what is the mass? Well, I know how much a chlorine 35 weighs, and that's 34.9689 U. And I know how much a bromine 79 weighs. A bromine 79 weighs 78.9183 U. And so the mass of the molecule is this. Can I just add these together? Can I add these together to get the mass of the molecule? Or do I have to worry about mass defect? Let me just take a quick survey. Just say yes or no. Can I add them together? No because of the mass defect, or no if you have some other reason why we can't add them together, tell me. Just give me a yes or a no. Tien? Veronice? Katrina? No. Actually, maybe I'll stop this.